OK, something we've used already, but we haven't explicitly called out, is two separate keys. So for example, in the encrypt then MAC scheme, notice that we used K1 for encryption and this totally different key K2 for MAX. Did we have to do that? What if we did something where we just used the same key? So we have one key and we encrypt with it, and when we compute the MAC, we use the same key K. You can do that, but you have reused a key, and when you reuse a key, you open yourself up to very subtle issues, and you have to think really hard about them. So for example, if the encryption scheme is based on a block cipher, for example, one of those block cipher chaining modes, and your MAC scheme is using another block cipher-based algorithm, so there are some MAC schemes that use block ciphers out there, well, then now you have a scheme that's using a block cipher and another scheme that's using a block cipher, and it's possible that those schemes interfere with themselves in very subtle ways. Maybe somehow, because you're using this K and this M, you pass the message forward through a block cipher, but then because you use this MAC with the same key, maybe somehow the MAC is passing the message backwards through a block cipher, and suddenly you get the original plain text back. So there's all these really subtle attacks where the fact that these two keys are the same can cause things like block ciphers to interfere with each other, and that might affect the security of your overall scheme. We're not going to show one of these specific attacks. Some of them are quite subtle, but the key point is you have to think about them, and thinking is really hard. I don't want to have to think really hard about what attacks are possible here. It's going to give me a huge headache, and the way to avoid all of those headaches is just use two separate keys. Now, even if the schemes somehow interfere with each other, you're encrypting with K1, and if the MAC somehow decrypts with K2, that's fine. That's a different key. You will not get the original plain text back. So even if there is interference here, using two keys prevents you from those interferences messing with your scheme. So this is better. We should always use two keys because it means we don't have to think as hard. You can use one key if you want, but then you're going to have to think really hard about attacks and prove to yourself that these schemes don't interfere with each other. Sometimes they don't and you're OK. Sometimes they do. I don't want to have to think about that, so I'll be safe and use two keys anytime I have two different schemes. So this attack that we just talked about, we call it key reuse. This is kind of an annoying term because people use the words key reuse in all sorts of different ways. So for example, when we talked about one-time pads, we said we were reusing keys there, and now we're talking about key reuse again. For better or worse, people use this term in all sorts of different ways. When you start working on project 2, you will probably call 10 different things key reuse, and that's OK. But just know that at least for this lecture, the way that we're defining key reuse here is using the same key in two different algorithms. So for example, encryption is one algorithm. It's one piece of code. MAC is a different algorithm. It's a different piece of code. And because I'm using the same key for both algorithms, I call that key reuse. Now, you can use key reuse to refer to other scenarios where you use the same key twice, but this is my specific case for key reuse and the lecture definition of it. And in real life, there might be other contexts in which the same key is used twice. So for example, if you encrypt a message twice with the same key, at least for our definition, that's not key reuse. You can call it key reuse, but that's not our specific definition. Sorry, it's a little bit confusing. Terminology is hard, and people like to use this term in different ways. But for our purposes, key reuse means same key, different algorithm. In real life, you can use it to mean same key, different message, or whatever else. But for us, it's same key, different algorithm. And our conclusion is don't do it. It makes your life harder. It makes you have to think. And I don't want to have to think hard if I don't have to. So the solution to key reuse is to not do it. One key per algorithm. So for example, if you want to encrypt something and you also want to MAC it, those are two different algorithms. So please use different keys for different algorithms. Or maybe you have a MAC for a message to Bob and a MAC for a message to someone else. That could also be a case where you want to use different keys. If you want to use the same key, maybe it's OK, but you'd have to think a little bit harder about whether it's OK for your purpose. Or what about if Alice has two files? Should she use the same key to encrypt or different keys? And again, that kind of depends on your threat model. At least from our definition, encrypting 2 messages with the same key is OK, because encryption is the same algorithm, so you don't get that interference. But maybe for your purposes in a project or something, maybe you want to use different keys. And thinking about these trade-offs is something you'll do in the project. So sometimes using the same key is OK. Sometimes using different keys is better. But one case where using different keys is definitely the right thing to do is when you have 2 different algorithms. Always use 2 keys in those cases. We don't want unnecessary interference. OK, so one concrete attack that people have actually built, and I won't talk about it in all the detail, is one where they use the insecure MAC then encrypt scheme. And remember, the problem here was that we give someone a decryption oracle. We allow the attacker to send any data that they want, and Bob is forced to faithfully decrypt it before he can check it for integrity. And there actually was an attack that happened on the early internet because MAC then encrypt was used. So way back when, people didn't really know that MAC and encrypt was strictly worse than encrypt and MAC. So they used MAC then encrypt. It caused an issue. And the result was encrypt and MAC becoming the better standard. So if you're interested, you can look up this attack. We've given you the name.